In this lesson, we're going to continue with inverse functions. We are going to determine if these two equations are one-to-one functions, and if they are, then we're going to find their inverses. So, first off, to determine if something is a one-to-one, we need to think about the visual and see if it passes a horizontal line test. So all square roots kind of have that look to them, roughly. And so that passes a horizontal line test, which means its inverse is going to be a function. So, first thing, we're going to rewrite this. And we're just going to get rid of the f of x and replace it with a y. Now to find the inverse, we are just going to switch the x and y. All right, and then we're going to try to get y by itself. And that when we get y by itself, that'll be the inverse function. So we're going to subtract 3, and I'm going to switch, we'll do x minus 3, and then square root of y minus 2. To get rid of a square root, we're going to square. And so this is going to turn into, this is where I'm going to switch this around. The square root and the square will cancel each other, undo each other. And so that's going to be a y minus 2 equals x minus 3 squared. Same thing, just I like to have the y's on the left. So we'll add 2. So we get y equals x minus 3 squared plus 2. And then we'll finish it with just kind of fancying up a little bit with just putting the f negative 1, which represents that it's an inverse function of this original function. And we have x minus 3 squared plus 2. Okay, so before we go any further, let's talk about what an inverse is. And we're going to see and make sure that we actually have an inverse. So we're going to check and make sure this thing is an actual inverse. Now we're going to check ish. So we're going to plug in a number, and I'm going to do two things to this number. We're going to plug it into the original and see what we get. And I'm picking a random number, but I'm kind of strategically picking a random number. So our x is going to be replaced with an 11. So, and there's a reason why I chose 11. I mean, there's other numbers I could have chose, but I'm trying to make this as straightforward as possible. And 11 minus 2 is 9, which is a square root, is a perfect square. So I could pick all sorts of different numbers, but I just want to make this as easy as possible. So I'm going to pick a number that when you subtract 2 from it, it makes a perfect square. So square root of 9 is 3, plus the 3 gets us a 6. So we plugged in an 11 and we got out a 6. So what we're going to do is take our output and put it back into, we're going to put it into this inverse function. So that's going to be a 6 minus 3 squared plus 2. And so if we do this math, 6 minus 3 is going to be 9. So 3 squared, which is 9, plus 2 gets us 11. So here's what an inverse does. 11 is what we started with, and that is not a coincidence at all. So the idea of an inverse is an inverse will do, or an original equation does something to it. So it did this math and it created a 6. If we plug it into an inverse, it perfectly will undo it and give us right back to where we started. So it's not at all a coincidence that if you have a square root in here, you're going to probably have a square in your inverse. If you have a minus 2, you're going to have a plus 2. If you have a plus 3, you're going to have a minus 3. It's just the challenge is to kind of what the order of this, to kind of perfectly undo exactly what we needed to do. And us just switching the x and y's and solving for y will always get us in the right perfect form. So let's do this next one. So this is a rational. Just a couple quick little things about it. This has a domain issue at negative 1/2, so we have a vertical asymptote at negative 1/2. We have a horizontal asymptote at since the powers match 5 halves, so that's going to be like 2.5 somewhere up here. And then if you set the top equal to 0, that's going to be your x-intercept. So our x-intercept is going to be a positive 3/5, so something like that. So we're going to have, our graph would look basically something like that. All right, and I don't really care that specifically. I just really need to make sure that it's a 1-to-1, so it passes a vertical line test, or it passes a horizontal line test, which it does. Perfect. So let's figure out what our inverse is. Now this one's tricky, and this one just needs a little bit of exposure, and then there's pretty much the same process every single time after this. So first thing is we are going to switch our x's and y's. So we're going to have x equals 5y minus 3 divided by 2y plus 2. My kind of go-to here always is let's clear out the fraction. So we'll multiply 2y plus 1 to both sides, and then we're going to distribute. So if we distribute, we have a 2xy plus x equals, this would have gone away, 5y minus 3. All right, so the challenge is we got rid of our fraction, that's great, but we're trying to get y by itself. And there's multiple y's, and we can't even combine them together because they're not like terms because the x throws it off. But I'm still going to pull the y's all over to one side, so I'm going to subtract the 5y to this side, and in doing that I'm pulling the y's to one side, so that means I'm putting the x over to the other side, so I'm going to subtract the x over. Alright, so we're going to have a 2xy minus 5y, they're not like terms, and then over here we'd have a negative x minus 3. They're not like terms, so they can't go together. So here's the trickier part, and then once you see kind of the first time, it always has this feel every single time after that. I can't put them together, but the fact that I put the y's on the same side allows me to factor out a common factor. So having two y's, but if you factor it out, you no longer have two y's. So that allows us to basically have y times something. We can divide that something over to the other side, and that gets us a y equals a negative x minus 3 and a 2x minus 5. We'll fancy up our final answer. Negative x minus 3 over 2x minus 5. And that is our inverse function. So this was a lesson basically on determining whether you have a function that's a 1-to-1. So it's basically just a visual, see if it passes a horizontal line test, and if it does, let's find our inverses and switch our x's and y's and get y by itself. And then we just kind of talked about what an inverse does. An inverse undoes whatever the original equation did. And we have one more that we're going to be verifying, but we'll do that in another video.